All right, now that we have data in R, we want to start looking at it, right? We want to start exploring the data set. First, we're going to do that looking at the whole data set and looking at a summary of it to kind of get a feeling for what's in there. And then secondly, we're going to look at particular columns in that data set and see how they're distributed, what types of variables they are, to kind of really get a thorough understanding of what we're dealing with. This is a really key step of any project, right? If you're going to do fancy statistical modeling or just a simple descriptive analysis of your data, if you're reporting data, it doesn't matter. The first step is you really have to get to know your data set. And this is what we're going to do now. So let's go back to R. I've opened our session in R here in our week 2 script. And there's one way of exploring a data set that you've already seen, which is just clicking on the data frame object here in your environment. If you do that, the tab opens, you already see what's going on. You see the columns, the rows, right? What you see the values already. You can sort of guess what type of data you're dealing with here. There are also commands to explore that. The first one is head, so head and then bracket students. And whenever I say command, I basically refer to a function, right? Commands are called functions in R. And head gives you the first 6 or so observations in any data frame. Looks pretty similar than what we explored. Sometimes this is useful just if your data is messy, for example, and you want to get a feeling for what the general structure looks like. You can just look at the first couple of rows in that data set. And it also gives you a list of all the remaining variables that are not displayed. The second command is structure, str bracket students, and it gives you a little bit more information. First of all, it gives you a full list of columns in the data set and their names down here in the console. Right? It also tells you how many there are. There are 23 variables and 1,000 rows, so 1,000 observations. The type of data set that we have here is a data frame, R's way of saying data set, and TBL, which is basically refers to Tibble, which means like a clean data set with rows and columns, a structured data set. Okay, and here we also get sort of the type of values that we have inside of the column, right? We see, for example, for faculty, there's a value called business, probably the business faculty. We have in the course variable, in accounting class. But then we have some seemingly numerical information here, for example, on the type of grades, life satisfaction, and a couple of other variables. Now, the glimpse command is very similar. It's just a little bit more condensed, right? But it basically gives you the same information. Now, onto the class function, which is an important one. The class function gives you information on what format of variable or information you're dealing with, right? What class of object you're dealing with in R. And remember, R organizes everything in objects. Data frame is an object referring to a data set. There could be objects like vectors and lists and matrices and variables and so forth. And it's always important to know exactly what you're dealing with, because once you feed something into R and tell R do this and that, it will assume a specific type of object to deal with. And if the object is wrong, your whole function will not work and you get an error message. So that's why figuring out the class of an object is important. If I run that for the whole student's data frame, I just get this information, which we had before, which is, well, the student's object is a data frame, right? You can also do this for particular columns in the data set, columns or variables, and you can type class brackets students $age. The $sign in R is used to refer to a column within a data frame or a column in a list or something else, right? We'll get to that in the future. But if you want to refer to a column in the data frame, you can use the $sign here. So if we run that, R tells us, well, the age variable, the age column in the student's data set is numeric. Okay. If I do it for country of birth, we'll see, well, the type of variable that country of birth is a character variable, which character variables are text variables, right? They use characters. So this is always written text and not a number, right? It's important to distinguish. There is another command which basically summarizes the whole data set called summary, and then in brackets data frame. If you execute that, you will get for every column in your data set, you get an overview. Now, for all the character variables, R can't really summarize them, right? So you just get how many rows there are and what class they are. However, for numerical variables in your data set, you do get a little bit more information. For example, the minimum value, right, 10, the maximum value, 80 here, in the case of age. You get the median and the mean. But we also see, well, their age seems to be the only numerical variable as of now in our data set. So I'm going to actually convert two variables into a factor type and numeric type, right? Don't worry about how to do that now. We're going to learn that in the next session actually, but I'm just doing this for the purpose of demonstration here. So now I converted two variables and I run the summary command again, and we see actually here for like and the variable term, we do get summary statistics now. Now, like is actually how much people like their courses, and it's a scale from 1 to 6. 6, they love the course, 1, they hate the course, right? So it gives you here a distribution of how many people answered in each category. And R does that now because we defined the like variable as a factor variable. Factor variables, very important in R. They're basically referred to categorical variables, right? Variables that have certain categories that are not necessarily numeric. They could be, like the like variable, right? Numeric in terms of they have numbers. But R just then understands, well, each category is displayed by itself. Numeric variables are basically variables with more numbers and a larger scale, right? Where you want to summarize in a different way. For example, using a mean or a median. The term variable tells you what term people are in, and it ranges from a minimum of 0 terms, so the first term, and 14 terms here. The NAs refer to not available. Those are missing values. And for 9 students, we don't have any information on whether they like the course or not. So this is the summary command. You can also use the summary command for specific variables. Let's do that again. Right, if you sometimes have a lot of variables in your data set, and you don't want to look at all of them, you can pick particular ones and just get the summary for them. We've already seen how to do that. So if I execute those commands, we get here the summary for those two variables. Now, let's look at specific variables and how they're distributed, right, regardless of their type. This you can do with just a univariate table, a frequency table, right? And a function to do that with is the table command. So you use table, you indicate the data frame that you're using, and then the column that you want to have displayed. I run that, I now get the frequency of responses, the frequency of rows, right, by the country of birth. And we see there are 91 students in Austria, 85 students in France, 153 students in Germany, and so forth, right? So the table command just summarizes the number of rows by particular categories of the response variable. We realize here, we know that we have some missing values, some NAs, but they're not displayed actually. And you can do this in the summary function by adding an option. Options are usually added in R after the comma. So you put comma, use NA equal, in quotation marks, if any. If you run that, you'll see now also you get the missing values, right? So using not available equals, if there are any, if any, then display them. Okay. All right, before we close for week 2, I want to show you one last function here, which I really like. It comes from a package that isn't included in base R. It's not already automatically loaded. We have to install it and then load it. And we learned how to do that earlier in week 2. So we're gonna, the package is called janitor, right? If you do not have it installed on your computer, type install packages janitor, right? Mark it and run it. And some code will appear here and it will be installed. Now I have already installed it, so I don't have to install it again. I just run it, library janitor, right? Within the janitor package, there is a function called table. Now let's use the help function in R to figure out what does table do, right? I want to get some more information about tables. So one way to do that is just type quotation mark table and execute that. And now we see here on the right hand corner a help file popping up, and it actually describes what table is and what it does. So let's see. It generates a frequency table, just like the table function we've seen before. A fully featured alternative to table. Results are data frames and can be formatted and enhanced with janitor's family of adorn functions. Okay, and it also lets you scroll down and it gives you some examples here, right? The key advantage of this command is that it's really easy to include more than just one variable. Maybe you want to do a cross tabulation where we compare two variables and also get some more information, not just the frequencies, but maybe the percentages, right? And this you can do with the table command fairly easily, and later on you can do more things with that table object. So we've installed the janitor package and we have activated it, we have loaded it. Now let's use it. So table, the name of the data frame, $, country of birth. We run that, we get here a table which has each response category, each value in the variable country of birth, like Austria, France, Germany, Italy, Netherlands, Spain, etc. We get the number of observations we have, the number of rows per category, but then also we get the percentage, right? We get the distribution in a percentage. So we know now, for example, that 15% of students in the data set are from Germany, okay? And 26% actually from Spain, 9% are from Austria, right? So this is how this table function works. Now let's go one step further and actually include a second variable to get sort of compare two variables with each other, right? This is called a cross-tabulation. And all you do is have the table function and then instead of one variable, include another one after the comma. So we want to look at the, sex distribution by faculty. So here we have all the faculties, and here we have female, male. And we see, for example, well, in the economics departments, there are more males and females. In the sociology department, they're almost equal. In the business faculty, there are more males than females, and so forth. Now, we also have the missing values displayed here, actually. And out of the 10 people where we don't have information, 7 are actually male, 3 are female. So you can also exclude the not available, the missing information, by the option show _NA and then equals false. So we don't want to show the missing values, right? You get the same table just without the NAs. You can also convert this in percentages. And you can do this by using the add-on adorn percentages. So let's do this step by step. First, we use students. We call on the data frame students, and then we use the table function, and we created cross-tabulation for sex by faculty without the missing values. And then we add percentages by rows. Okay, let's run that and see what it looks like. And we actually see that now it's the same table, but the the frequencies are converted into percentages based on the row. So the rows here add up to 100%. Okay, and now we see 16% of all females are in the economics faculty. Okay. We can add some more formatting tricks, like we can add, limit the number of digits here just to 1 rather than 6 or 7. And we can also add actually the number of observations. And we do that in each step by using this sign. And you see here in the table, we now have percentages, and in brackets after it, we have the number of observations. All right, note that we're not yet producing any tables, right? So this, what I showed you is just to get a feeling for the data set, get a feeling for individual variables and columns, not producing good-looking tables. We're going to do that actually in a later week. So don't get disappointed because the little tables here look, a little dry and not very pretty. This is actually not what we would use to report in a paper or in a report or anywhere. And this is just for us to understand the data that we're dealing with.